Hey friends, you're watching BrainStormAcres. I'm Henry. I'm back down in the studio today. I want to give a little more information about how I went about diagnosing the problem in Irene's studio. I had several questions about what happened. Well, let's go ahead and take a look at this. Until last fall, we had the same kind of setup for our house. We have 6 2-volt batteries that are connected in series. That makes a 12-volt battery bank. Now this right here is the offender. That is a slow blow fuse. Now the supplier of the inverter recommended this specific fuse, but I think they were a little bit optimistic about how much current their inverter could handle. When that fuse blew, there was no electricity left in the entire studio, and there was a terrible smell. A few words of caution. Before you work on any kind of system like this, you need to have some basic understanding of electronics and electricity. Some of these things can be fairly dangerous, and you don't want to be taking chances. At the time that I put this system together, I would have preferred to have used a circuit breaker. Circuit breaker simply will trip if the current goes too high. Fuses will blow. Ideally, there'd be another switch in this circuit, but as you can see, the lead for the battery connects directly to the post of the battery. It goes on up to the fuse. The fuse then protects the inverter. One of the problems that I discovered with this inverter versus that fuse is this inverter is good for about 2,500 watts. That's 2,500 watts total, or 2.5 kilowatts. That fuse is a 300 amp fuse. That's about 3,600 watts, or maybe a little bit more. If you don't understand high power electronic design, stay out of an inverter. It can be very dangerous. I started my analysis of the problem by removing this wire from the battery. There was no spark or anything else like that because this fuse was blown. Solar power for this inverter comes from this charge controller. The solar charger has circuit breakers that can disconnect the solar panels from the charger. Our system here has one more source of power, and that is a wind generator. I'm not using it right now because I don't have a way of turning off that power, so I just have it disconnected. Now what makes our system unique is this transfer switch right here. If I push this switch up, it will take power from our house in order to supplement the power here in the studio. When I first started my investigation, I removed this wire. I then checked the fuse. The fuse had been blown, so I knew that I at least had to switch that fuse out. Before I did anything else, I made sure this transfer switch was in the off position. I made sure that the wind generator was not connected. I switched off the solar panels. Now I had a system that shouldn't have any power going on anywhere in this inverter. My next step was to replace that fuse. When I connected the cable back up to that battery terminal, there was a big spark. That's one of the reasons why I would much rather have a circuit breaker or a switch. I'll be replacing a lot of this with the system that came out of the utility building that used to run our house. Once power came on, and this inverter has a couple of LED lights that tell you that there's power coming in, I switched on the solar panels. I didn't need to switch on the wind generator because I'm not using that. And I didn't want to connect the transfer switch to the house because if there was a problem with the inverter, I didn't want to be causing a problem in the house. The problem was caused by a combination of this kiln, which Irene uses for enameling, and the charger for the electric chainsaw. We have multiple branch circuits in the studio. All the branch circuits have circuit breakers. Each of these circuit breakers is capable of handling 20 amps, or about 2400 watts. There are 3 of them, which means that there can be about 7,000 watts drawing from the system. That's not a problem because normally we don't plug in all of that equipment all at one time. We will run a generator on the outside to supply the additional power. Well, I hope that provided some explanation of what happened last week with Irene's studio and how I went about diagnosing it. If you're working around batteries of any kind, especially large batteries that have large capability like these batteries do, make sure you remove all metal jewelry, wedding rings, necklaces, anything like that. Because if you accidentally short the circuit out with any of those things, it's going to get very hot and you're going to get burned. That's the very least that can happen. There could be other problems as well. Now, this system here uses a 12-volt battery. That makes it safer, but not safe to work on. There are many, many hazards with solar systems. The batteries, if it's lead-acid batteries like these are, can spit acid at you if they start burping as they charge. So you want to wear some gloves and face protection, at least wear some goggles or protective glasses so you don't get hurt. Better yet, take a class at a community college or talk with a solar installer, somebody who works with this stuff all the time. You're responsible for your own safety. Make sure you understand what can go wrong. It isn't something to be really afraid of, but you want to make sure you understand before you really start messing around with it. Well, let's go take a look at what I'm doing up in the yard for the irrigation. It's windy, windy, windy again. It's spring in the northern Arizona high desert, which means we have wind. We may have snow tonight. Well, we probably will have snow because they've changed the weather forecast twice in the past 10 hours. Well, let's get going.